So that's kind of just a quick definition of those things. Let's talk about some trivial examples related to polynomials. So these kind of things come up a lot, and a lot of students kind of get confused on which ones represent which. If we're adding two linear terms together, we can combine them together. So x plus x, that means there's two x's there. And you can always prove these things by putting in examples and seeing if it works out, or disproving them by putting in a counterexample. So if I add two things together, that's the same as multiplying that thing times 2. So just try it yourself. 10 plus 10, is that equal to 2 times 10? Is 5 plus 5, is that equal to 2 times 5? And you would see that, yeah, this is always going to be the case. That you can add two things together is the same as multiplying by 2. When you multiply something times itself, this is actually squared. So this is equivalent to x squared, and you can see that 10 times 10 is the same as 10 squared. And this is just by definition what an exponentiation, what exponents are. Is the number of times that you multiply it times itself is exponentiation. Okay, when we divide something by itself, you get 1. So that's kind of a trivial case. Trivial just means that once you understand it, it's obvious that you can just pull that information out of your head. Now, this is not always the case. X cannot equal 0, right? This is one exception. You cannot have x divided by x when x is equal to 0. 1 times x is just x by itself. Anything times 1, so 1 times 5 is 5, 1 times 10 is 10. Now 1 plus x, this cannot be simplified because a constant term and a linear term cannot be combined. They're two different things. So it doesn't get simplified at all. You could switch the order and say x plus 1. But you can see that 5 plus 1, you get 6, right? But 10 plus 1, you get 11. So you can't say it's related to the value in any different way than it's the number plus 1. Okay, 0 times any number is always 0. So this is a case when sometimes you get a polynomial like this. So what is the cubed term and what is the linear term? They're left out. Well, you could expand this and write it as 0 times n cubed plus 2 times n squared. And because adding 0 just drops it out. 0n plus 1. So this is kind of the expanded version, but really 0 times anything is just 0, so it goes away. Yeah, so and then adding 0 to anything is just the thing itself. It's kind of this is the identity property, and this is the identity property of multiplication, identity property of addition. This coefficient here, so I like to break this out and say the coefficient here is really 2/3 times x, and we can kind of test that. So 2/3 times 3, is that the same as 2 times 3 over 3? Right, 2/3 times 3 is 3 over 1, so 6 over 3. And is that the same as 6 over 3? Right, it checks out. So a lot of times you want to break off this little coefficient and put it out in front. This is called the zero product property, ZPP. That if you multiply two things together that are equal to 0, one or the other has to be 0, right? So A is equal to 0 or B is equal to 0 would be solutions to this, or they could both be 0, right? These two things are not equal to each other. X squared plus x is always equal to x squared plus x. You can't combine those two. They are not like terms. But x squared times x is equal to x cubed. X squared, so 10 squared times 10 would equal 100 times 10, which is 1,000, which is the same as 10 cubed, or 5 squared times 5, which is 25 times 5, which is 125, is the same thing as 5 cubed. So this can be reduced into x cubed, but this cannot be reduced because you cannot combine these. They are not like terms. So we'll talk about that a lot. There's terms and then there's factors. Factors can be split apart, but terms they're always split apart unless they have the same exponent. Then they can be combined.